The history of the atom. It all started with a 2,000-year-old question. Let's jump in the chemistry time machine and head to Greece, 100 BCE. A Greek guy named Democritus was wondering what would happen if he cut an element in half infinitely. Would he eventually reach a point where he would no longer have the same element in his hand?
If I had a certain amount of a pure substance, and I cut it in half, then cut that in half, and then cut that half in half, and so on.
Democritus hypothesized that eventually you would get to the smallest piece, which you could not cut in half anymore.
I'll call this tiny indivisible particle an atom.
The Greek word for indivisible is atomos. Know your roots? Atomists realized that all of the atoms in a certain substance must be alike, but different from atoms of another substance. For a long time, no one remembered anything about atoms until England, 1820. 2,000 years after Democritus, England chemist John Dalton was studying the weather and reactions between gases. He noticed that two gases always combined as if they were made of tiny particles. After conducting many experiments, Dalton came up with the following theory. All elements are made of atoms, which are indivisible and indestructible. All atoms in the same element are identical. Atoms from two different elements are different from each other. If you join two different types of atoms together, you will make a compound. This is known as Dalton's atomic theory. Fast forward to England, 1897. Discovery. Sending electric current through neutral gas gave off rays of negatively charged particles.
If the gas has no charge of its own, where are the negative particles coming from?
Thomson was the first person to think that atoms could be made of even smaller pieces. He figured the negatively charged particles coming from his neutral gas atoms were coming from inside of the gas atoms. He discovered electrons.
I know. These negative particles must be balanced by positive ones inside the atom to make it neutral overall.
So, Thomson created his famous plum pudding model of the atom. He thought of atoms as tiny bowls of plum pudding. The electrons and protons are scattered around like the plums in the pudding. 11 years later, England, 1908. Ernest Rutherford was firing rays of positively charged particles at a piece of gold foil. Most of the particles went straight through, and only a very few changed their course or bounced back as if hitting something solid. But if foil was made of millions of gold atoms, could his beams go straight through as if nothing were there? Rutherford's knowledge of physics helped him to design this model of the atom, improving on Thomson's design. Occasionally, a proton hit the nucleus full of other protons and repelled strongly. Most protons were traveling right through the gold atoms because of all of this empty space. Some protons were hitting electrons scattered out here around the nucleus and were deflected. Rutherford also figured out that if the atom was stretched the size of, say, a football stadium, the nucleus containing the positive particles would be the size of a marble on the 50-yard line. That's a lot of empty space. 5 years later, Denmark, 1913 ACE. The next improvement to the atomic model came from Niels Bohr, who theorized that the electrons surrounding the nucleus were not just scattered around everywhere, as Thomas and Rutherford said. Bohr compared the electrons of an atom to planets orbiting the sun, circling the nucleus in a specific place or energy level. In the 80-plus years since Bohr's work, modern scientists still consider the Bohr model a good basic model of the atom. However, results from further experience with high-tech equipment have shown that 1. There are neutrally charged particles in the nucleus called neutrons. 2. Electrons move so quickly around the nucleus that their behavior seems like that of a wave. Scientists often draw electron clouds that surround the nucleus. These clouds represent the most likely places the electron will be found at any time. Scientists have also succeeded in splitting the atom apart and having found numerous subatomic particles, But that's another story. The end.